Okay, welcome to this new video lesson about the client-server laboratory hub architecture that we have put in place to support the practical activities of the well-being course. So the idea is to provide a very easy and effective way to collect the geographically distributed data, and everything must be made available on the database. So we wanted to keep it simple and straightforward, so that we can read by means of a very easy web application, web pages, some easy web pages. We can read the database and display the data, and also we want to make it easily expandable for future application. It's a very lightweight server application, multi-threaded, and support different technologies for connecting to the server. Well, just a quick note now. It's possible that now more up-to-date technologies or more innovative technologies are available to do this stuff. But this was some years ago when we started to work on this project, and it was easier to work in this sample architecture. So it has to be considered just a simple tool to develop client-server application. Probably now we could use also Node.js or other multi-threaded server applications, server technologies, but keep it as a test laboratory. So the architecture is based on a virtual host, virtual machine named Aphrodite, and with a database which is called SensorDB, and it's a MySQL database running on the server. The client test program can be is being developed in Linux, and also the server has been developed in C on Linux. There's also another client program for testing Android applications. Again, it's a basic skeleton that contains very elementary basic functionalities, but it's good to start with. Development of a new application and interfacing IoT devices, maybe IoT devices or sensors and so on. The connection protocol used is TCP/IP. So on the server side, we have a MySQL database with PHP MyAdmin configuration suite uh, for creating stuff inside the database, and we can connect it to the client to the server machine with a Windows client or SSH or Linux SSH client. We suggest that you use PUTTY for Windows connections, but if you have a Windows subsystem for Linux installed, you can also use the terminal, the Linux terminal inside Windows, which is pretty powerful and contains also SSH by default. So Event Hub is up and running on port 6969, which is our default, but we can change it if necessary, if you want to port it on another machine. And we also implemented some basic, very basic parsing functionalities for JSON in C, because at the time of development there were no stable libraries, there were no easy to use libraries for JSON parsing. So for the basic functionalities we wanted to introduce, it was enough for what we did. Database tables are only two. As I said, the structure is easy, the easiest possible, but we want to keep some requirement that only event types that are registered on the system can be stored and collected, and so we define a table that is event types, which establishes how many event types can be recorded, and the raw events stores the history of all events that we collect according to their event type. And event type table definition is simple. You see here we have a short description apart from the primary key, which is due for obvious reasons. We have a short description and a long description and the timestamp, which is the creation timestamp of the record. And if you want to go to the raw events table definition, you see that apart from the primary and foreign key that again are useful for the design of the database, we have the meaningful data are the timestamp, a double value for storing whatever is read from the sensors, and also metadata to store any textual values or many additional values that can be base64 encoded. Again, it's text, so it's easy to encode the data in base64 and send it over the TCP/IP connection. Why we chose JSON? JSON because it's a standard, it's multi-language supported, and it's very easy to handle in the web applications as well. So because it's supported in JavaScript and in many other languages. So the data structure for the event is very basic and simple again, and we have an event type which is the lookup key that we use to check if the event is recorded on the database and can be accepted, of course. Then we have the value and the timestamp, and eventually we have some base64 encoded metadata that can be additional data to support the value that has been calculated some way or that contains some useful additional data. And a quick note on base64 because it's again a standard that has been introduced to send to convert binary files and attach them into the emails. So there is at the moment no particular reason for using this version, but it's supported for possible binary transmission in future applications. Again, it was thought as a future expansion. Maybe now we can do better with other technologies, but still remains for basic basic testing in this case. So all event messages must be base64 encoded before sending, and metadata must be encoded as well before being added to the event record. So there's a double encoding inside. And you have the basics, the base64 library that we developed for decoding and encoding messages. On the server side, we have a connection handler that each time a new client gets connected, fires a new thread, and processes data in this way. So decoding the message that has been received, we read the message, we decode the message, we store the parsed messages, so we create an equivalent for the message into the database, and if of course the message is supported, and then we clear the message buffer for a new read. Very easy, really easy. How to store the message? What is done in the function is that the message is parsed. So we get the metadata, we unpack the metadata, we prepare, sorry, the buffer for the metadata, and then we retrieve all the values that are stored in the database. So in the message, sorry. So we have get string, and we retrieve the event type, metadata, the sensor ID, and the timestamp, and we also get the value, double value. Then everything is assigned to a variable, and then if the metadata is present, we must undecode unpack it because it's packed again in base64, and so we put it into an unpacked metadata. And so we can select from the database, we select the event type, okay? We want to make sure that the event type short description matches what will be read from the message. If it is present, we move forward. So we assign what we need to complete the to complete the message, the storage, and then you see here the final command is to insert into row events and so on. Again, here it's clear that this approach can be subjected to SQL injection attacks, but again, it's a testing application, is not a production application. All this select and insert should be changed if we want to make it safer for and secure for production environment. So the same a similar approach has been used to build the application on Android. So we have a main activity for the application setup and data hub configuration, because you need to specify the target address, IP address, the port, and so on. And then a background service is necessary, because we want to send the data. If we read the data from sensors, we need that this data is sent at a fixed rate to the server. And also because we have a problem here in the fact that generally Android broadcast messages about sensor reading anytime a new data is made available on the sensor. So there's a lot of information running, and we should filter some data, maybe send only some meaningful data and not everything that we collect, because we risk of clogging the network. So we risk of having too much data moving from one side to the other. So we need also to schedule the time frame by which we collect data and send the collected data, the average probably of the data, depending on what is the application that we want to use. So we implemented only the very basic functions, and not all the sensors that are supported on a mobile phone are currently supported by the application, but it's possible to expand. The application supports Bluetooth, low energy beacon scanning and ranging before sending data to the hub. This is mainly useful because if you want to make indoor localization applications, you can do it by simply expanding the basic functionalities implemented in this test application. And there's a sample code for trapping pressure sensor events via the sensor event listener. So here you see how to access the sensor, and I implemented also a kind of session of sensor pooling just to support what I said before, that we do not want to overload the net. We don't want to send data continuously anytime a new sensor makes data available, but we wanted to pool those data and send at a specific time frame to avoid network overloading. Okay. So sensor pooling, as I said, is useful, and in this case, you see that the code for sensor pooling supports the fact that if the number of active sensors is whenever the number of active sensor data has been collected, that it's equal to the number of sensors installed, well configured on the system, we can create a new async task that sends data to our server, and then you have a new setup for next sensor time. So when we want to send the data or collect the data for next reading, and we clear the number of active sensors. Push data async is an asynchronous task that is created to establish a connection and send data in background, and then finally close the connection. So anytime we need to connect to the server for sending some data, a new thread is open, and this thread performs the operation and closes down, shuts down, removing useless memories in storage, removing the not without keeping the connection on active for all the time. So our device is not always connected. It's connected only when it's necessary. So if you use a time frame, a pooling time frame, which is not too frequent, so it's every 30 seconds, 1 minute, and so on. So you save a lot of power in terms or network traffic, because only when necessary we get the connection and send the data. Uh, the push data async calls this function send event data to effectively send the data on the connection. And you see here the counterpart of the decoder, in which of the server, in which we first encode all the data, and we send it. You see, we encode the data, we send everything on the socket. We open the socket on the port and so on. We send the stream and then close everything down, and eventually catch an exception if some problem happen on the network connection. So thank you so much for following this presentation.